Hey, how are you doing, guys? I'm Dahan. In this video, we are going to talk about what is the internal API of fastai. So let's get started. So these are our outlines for today's video. So first of all, we are going to talk about what is PILimage, how does it works, what is TensorPoint, and what is PointScaler. So let's get started. Okay, so we'll start by installing fastai library by using this line of code here. And for today's video, we are going through a very basic example of how to take an image and convert it over into how the pipeline expects, along with an example y, which for our case will be points, because we have to worry about both creating the object and how to deal with the transforms. And here we are going to import all from fastai.vision.auth. Okay, so for the first example, we are going to use an image of a cat. And here's the URL of the image, so we can open it. So this is the image that we are going to use for the first example. So we pass the URL of this image here to URL variable. Then we are going to use the URL variable to download URL method to download this image for us. Okay, so now let's see what is PILimage. So if we call PILimage with double question marks, we can see it's coming from fastai2 Vision Core. So PILimage is just a class that inherits from PILBase class. Okay, so that doesn't tell me anything. So let's go one chapter below into PILBase. And from here we will start to see what exactly this object should really looks like. So from PILBase standpoint, everything should have create and show function. Okay, so let's break it down to you. So PILBase class extend image.image, which is come from PIL library. So if we go here and we call image.image with double question mark, we can see it's just an object that comes from PIL library. So here we say that we expect some sort of PIL attribute. Okay, so as I said before, we want a create function and show function. So anytime we have a data type we want to use, we need a create and show function. Create prepares a file for converting to a tensor, and show is our show method. So we can see this by calling PILimage.create and pass it the path of our image. And here we store the results into im variable. Then we call the show method to show our image, and here's our cat. Okay, so what we have learned so far, we have learned that each item type needs a create and show method. So how does this relate to ImageBlock that we show in the previous lessons? So ImageBlock is just a function that has class type of PILimage, and we want this function to return this transform block. So this transform block calls class.create and apply some sort of batch transformations, which is into float tensor. Okay, so that's a very basic example of what an image would look like. So we assume whenever we get our types, it's going to be PILimage.create, and batch transforms will convert it from into float tensor. So how would this convert over to a non-image? So let's take a look at points. So points is just your x's and your y's. Okay, so if we take a look at the point block, we can see this transform block again that calls TensorPoint.create, and now we have item transform that calls PointScaler. So let's break this down into two parts. The first part is going to be for TensorPoint, and the second part for PointScaler. Okay, so let's go with the first part, which is about TensorPoint. So the goal of TensorPoint is to get an input of list of these x's and y's and convert it to a tensor. So the goal of TensorPoint is to turn a list of points into a tensor that we can work with. Nothing about transforms, just generating some form of raw input. So now we are going to define our custom tensor point, and we are going to compare it with the source code. Okay, so now we can go ahead and create our custom class. So our custom class, which is named myTensorPoint, is going to inherit from TensorBase. So basically what you need to know about TensorBase is that everything that you want to return will be a tensor of some degree. Then we are going to create our create function that takes t as an input. So what is t? T is a list of some points, and we want this function to return a tensor from these points. So it's gonna take this list and convert it to a tensor, and we set this tensor to be 1/2 tensor, and we make sure that every point is going to be float. Okay, so let's try to improve it a bit more. We also want to be careful about our image size, as we may need it for when we transform our image. So let's go ahead and make that as an input. So as you can see here we make our image size by default is equal to none, and we pass it to our return part here. So here we make our image size is equal to image size, that we will pass it to our create function. Okay, so let's try it. So here we grab the shape of our image. So the shape of our image is 19 and 27 by 23 and 70 pixels. Then we make some random points. So here we made 2 points. The first point is 1000 by 100, and the second point is 200 by 300. Then we make some tensor point out of them. So we pass our points to create functions that we defined earlier. And here's the return of our create function. Okay, so now we need the show method. So as I told you, we need two methods, the create and show method. Now we have our create method. Let's build our show method. So for our case, since we are working with points, so we will go ahead and use the scatter plot. And the assumption that we are going to make is anytime you want to show the points, you are going to pass them on top of an image. So we go ahead first and make sure that the fixed size isn't on our show. If it is, we want to use it and not the default keyword. And then we take our tensors and bring them back into view. And from ahead, we are going to make our scatter plot on our axes and return them. Okay, so let's try this. So here we create our tensor points as we saw before. We are going to pass our points to my TensorPoint.create method. Then we try to show our tensor points, and here's the error. So remember that I told you we need an image to overlay our points on top of it. So instead of doing this, we are going to show our image. Then we pass this image to our TensorPoints.show method. So as you can see here, the points are overlaid on top of the image. Okay, so now there is a few other bits that we want to do. Let's first make my TensorPoint.create into a transform. So as you can see here we make my TensorPoint create object, and we say that it's a transform based off my TensorPoint.create method that we just made. So anytime we deal with this point, we want a loss function of mean square error loss flat. So let's do this. So here we give it the property of a loss function and we declare it as mean squared error loss flat. And then we go ahead and replace the original .create function with our new one that has a mean squared error loss flat as a loss function. Okay, so let's see how close we are to the source code. So the only thing that we didn't have is the show arguments here. So that's just whenever we call the show method, we assume that the color is red and the marker is dot, etc. And otherwise is exactly the same. Okay, so for now we can create this sort of 1 by 2 tensor that will overlay on top of an image. But what if we start applying transforms such as resizing the image? How do we make sure that they get affected and scaled accordingly? Because right now they won't. They will just output and assume that they never changed. So let's go with the point scaler. Okay, so remember that the point scaler is in the second part of our transform block, which is our item transforms. So the point scaler is an item transform, which means it occurs each time we call the particular item, not when it's turned into a batch. So item transform done first, then we turn this item into a batch. Okay, so now how do we deal with this? So transforms have the following structure. First, we have the order. When does it occur? So if we have an order of 1, then it goes first. Then we have setups when we prepare our data. Then we have encodes when we are transforming our image. And the last thing, we have the decodes when we are decoding our image. So let's walk through to the start of point scaler. We wanted to scale our points and possibly operate different if we pass in y than x, instead of passing at x and y. Okay, so here we wanted to have the order of 1 because this is going to be happening first as we do our item transforms. Then we go ahead and keep track of do we want to scale our y's and will they go first or not. So as you can see here, the doScale argument have the true value, so we want to scale our y's. Then for our y's first is false, so our y's doesn't come first. Okay, so for now let's grab some setups. So we want this to take the total available points on our dataset, and we can use .numal to see just how many they are. So as you can see here, we take our tensor points that we defined earlier and do .numal on them, and you can see here we have 4. Okay, so for setups method here, it takes data loader as an input, which is DL here, and use this data loader to determine the number of points in the dataset. So if the dataset contains a tensor point object, then the C attribute is set to be equal to the number of elements in the tensor. Okay, so from now, how do we go into encodes and decodes and how they work? So during the transformation process, they work under the assumption if I have a particular type available to me, then I will run the transformation on it. So as I told you, they work by saying if X follows a type, and if so, we will perform it. So we want to see what's the current size of our points. So let's make a helper function that help us to get the size. Okay, so this grab size function here will help us to see what our current points are. So this will just take the shape of our x and make sure it's a tensor. And if not, then we will just call the size. So now let's make an encodes and decodes, which just grabs the shape of our points if we have an image. Okay, so what we want to do here is if we have an image, go ahead and grab our y's, which is what our points are. So we have encodes here that take x as an input, so x will be PILBase. So remember, PILimage inherits from PILBase as we saw, and x also can be TensorImageBase, and we will return the size of our y's. Okay, so now let's make a new method. So this method will should easier scale or unscale our points based on a transformation. So we'll make a simple scale points function to scale them together. So here we make a quick helper function to scale our points along with the new size, and here is the formula for doing the scaling. So let's try this. So here's our tensor points that we defined earlier. So we have 2 points. The first one is 1000 by 100, and the second one is 200 by 300. Then we want to scale these points to an image. So this image will be 224 by 224. And as you can see, here's our points are scaled. Okay, so let's look what would a point at the end of an image look like. So here we print the shape of our image again. And these 4 points here are the 4 corners of our image. Then we pass our points to our TensorPoint.create method that we defined earlier. And here's our TensorPoints. Then we show our points on our cat image, and as you can see, our 4 points in the corners. Okay, so now we can scale these points. And as you can see, here is the result. So the first point was 0 and 0. After scaling it, it will be -1 and -1, and so on for other points. Okay, so let's try this on a different image. So here's the URL of the new image, and we are going to use download URL to download this image. Then we are going to pass our new image to PILimage.create function. And here's the shape of our new image. And again, these 4 points will be in the 4 corners of our image. Then we pass these points to TensorPoint.create method. And here we show our image with our 4 points. And here we're scaling our 4 points, and as you can see, here is the results. Okay, so now we have them scaled, so we need to undo it. So basically, we are going to perform the inverse of the formula that we have above, and we pass it the image size. Okay, so here's our scaled points, and we need to get them back. So we are going to pass these points to my unscaled points method that we defined, and as you can see, here's our original points. Okay, so now we can transform our points based on a new image size and then have it be cropped, rotated, etc. Okay, so let's compare what we have done so far with the original base code. And as you can see that we are really just working directly with what's going on there. So that's it for today's video. Hope you enjoyed.